Let's continue with our LeetCode top interview 150 questions. We have done 3 in sliding windows. Now last one, minimum window substring. Also a hard problem, so it's gonna take a while. We shall see. Alright, start the timer. Let's see. 2 strings SNT length of MAN. Return the minimum window substring of S such that every character in T is included. Okay. Answer is unique. Minimum window substring of S that includes all the characters in T, including duplicates. So T is ABC, so that's gotta be at least 3 letters. We have ADO, that doesn't work. ADOB doesn't work. No. Here. Okay, here we have ABC. Oh, that's 0. Okay, it's not O. Oh, wait. What does it say? Oh, only upper and lower English letters, so that is O. So here we have the first substring that contains every character in T. So we have A, B, C. So that's the first one we found. Now what do we do? So this is the second B we see. We have, but there is no way to take any substring here that contains ABC. Okay, and then so this, when we have another A, we can discard the first part, and we see there's a B, so we can also discard that part. So this part gives us CBA. Then we look at, now we have another C, and we can discard the first C part. We have B, A, and C, which is the final result. But we need to figure out the algorithm to do this systematically. Okay, A. So that's the example we are gonna work on. So that's the follow-up. Let's just try without the follow-up first. Okay, seems pretty difficult. Sliding window, let's think. Sliding window. So first step would be to find the first window that is valid. So this is the first window that contains all the characters we want in T. So now what do we do? So when we see another B, we cannot really remove anything and make it shorter because we still need that A. So only when we see another A, that's when we are able to remove that part. But in this case, we also have 2 B's. So what if we kept the index of A, B, C? Then when we see another B, we update that index. So now we have the index of A, B, C like this. And then when we see another A, we can just start from the smallest of those indices. So if we do that, I'm not sure that's gonna solve for all cases though. It's gonna work for this example. So we really need more examples to cover more scenarios. We need more examples. Let's just make up some examples here. So let's see, S is let's still use A, B, C and one extra C because it could be duplicates. And what do we have here? Let's say E. Every character is included, but it does not have to be in that specific order, just as long as the character is included. Okay. And also the answer should be unique. What if we do something like this? So we need ABCC. We have ABC here. Here we have ABCC. That's the first valid window. Now we go forward. We have another B, which means we can remove the first part, and this will also be a valid window, A, C, C, B. And then we continue forward. We have another C here, which means we can take from this C. Oh wait, we have to keep our A, C, B, C. And now we have another C, but we still need that A. So we cannot get a shorter window here. Now we have a new A, so we can remove that. And we actually have two C's already, so that would work. So the tricky part, it seems to me, is when, okay, so we have B, C, A, C. So when we get a new one that's the same as where it starts, the B, that seems to be easier because we can just remove that from the window and then find a shorter, potentially shorter window. But when you have the C, that's still the first one. C. So this A, C, B, C. So we have A, B, C, C here. And now the next one is C. So it's not the same as the starting character. What does that mean? So in that case, we're actually not able to shrink this window, but we do need to update some index. So when we do run into the same start again, we would ideally be able to recognize right away that we can remove that C as well. Wow, this is indeed a very hard problem. Especially now there are duplicates. Without duplicates, a little bit less complicated. Okay, so let's say we use a dictionary to store the characters in T and their index in string S. So since there are duplicates, how do we handle that? Okay, what if we don't use a dictionary, but instead, since we only have English letters, we can use an array and then just simply use 26 letters, and we will be able to find each letter with constant time, which is the point of using the dictionary. So then at each position we will be able to store more than one well, I mean, we can store more than one value in dictionaries as well. For the same key, we can have a list as value, and the list consists of all the indices we want to store. Yeah, I guess that should work. Okay, we want a dictionary. How we do? So we put T into the dictionary. Oh, one more thing, if length of S is smaller than length of T, then we know there is no solution, we just return empty. Okay, so we have T put into this dictionary. But the values, I want the values to be a list, I think. Okay, I'm not sure if that's gonna work, so let's just try with the traditional dictionary first. So we have a dictionary for each character in T. If it's not in the dictionary, we we wanna put in the dictionary and give it frequency 1. Otherwise, we can increment its frequency. I think there must be some Pythonic way to write this part. I have to look it up. I would like to look it up. So we have this dictionary of T now. Wait, we do not want the frequencies. Wait, what do we want? We want to store all the indices. But we also need to know its frequency. We need to know there are 2 C's, and we also need to store both of them. Oh gosh, this problem is so hard. Not quite sure if I'm able to solve it at this point. Okay, dictionary. We want the frequencies, and we also want to store the indices. Okay, we might need 2 dictionaries. Okay, this dictionary I want to use for indices. If it's not, the dictionary. Then we initiate a list. Oh, what's happening here? Letters. What do we have? A letters. Letters array. Upper and lower. Okay, it is upper and lower, so it's not enough with just 26. I mean, do we use the whole Let's use the whole table then. So letters. Otherwise, we are gonna be using this A to Z and then A to Z, but they are not exactly continuous. So let's just use the whole table. So there we have our letters. So I'm hoping this will just give us the index right away. let's see if that works. So usually we do something like that will give us if A is at position 97, then that will, if it's B, it will give us 1. If it's C, it will give us 2, and so on. So, I mean, I guess we could make that work. 65. We're going from 65 to 122. So how many are those? Okay, 35, 57, 58. 58. Okay. That should put it into place. It starts from 0 and then it increments to count frequencies. Frequencies. Okay, we have our dictionary to store the indices and the letters array or list to store the frequencies of each character in T. Now, how do we do the sliding window? So current character is SI. So what do we do here? So we found a character that should be in this window. Okay, if C, if letters this has frequency 0, that means it's not in T. But we don't really do anything. Okay, for now we don't know what we'll do, so right now it's doing nothing. We can remove it if it's useless. If it is okay, let's write if this is if this letter is in T, then you want to decrement. Okay, to mark that we have found it. So we found A. Next round it's D. Nothing happens. Then we have O, nothing happens. We have B, we decrement. Then we have E, nothing happens. C, we have C in T, so that decrements as well. And now we have found one substring that is a valid window. So first of all, how do we know? Now we have found it, so letters should add up to 0. But we don't want to check that every single time, because that's gonna be a unnecessary operation. What if we have something like a count, and then each time we have found one, we increment count. If count is not equal to length of t, if we have found exactly this many, then we have a valid substring. Valid substring, what do we need to store? Length. Cannot use length of S because it might be the case that T is not in S, and then we should be returning empty. Let's use length of to start, okay, but it needs to return empty if T is not in S. Okay, so we have the length. If we have found a substring that works, then current length would be I minus, we need a start of the window as well. Starting from 0. So that's the current length. Or maybe what we need is a start and an end. Start index, end index. So maybe we still need that length. Okay, so if current length, if I minus start plus 1, is a smaller length than the last one, then we set end to current index. And we set length to b. And +1. Okay, so that's when we have found the substring. We have found this part. What else do we do? Okay, next round we have O, nothing happens. We have D. Okay, so we have D, we already have a D. Increment plus count. You also need to put this in the dictionary. And that's the index for that character. Okay. Now when we see a new D, what do we do? Do we want to update the index or store both indices or what? Next time we see a, I think we would like to update. Okay, so for now we have dictionary with A, B, C in there. Oh, D is not even in T, so that's, but we still need to consider that case. A, B, C is in there. So B, okay, so this is what we need to consider. B. This also needs to be outside. Okay, so now we have B. Wow, this is a difficult problem. Okay, B. So letters B that is currently standing at 0. So if this is in the dictionary and current frequency is 0, that means that we have already found it before. We already have that in our current window, and what we want to do is to update. We want to update the index, but it's not as easy as just replacing it because we might have duplicates. So we want to replace the smallest one. We always want to replace the smallest one and put in the bigger. So okay, so we need, instead of a list, we need a queue. So we put in the smallest one, and then we can dequeue. This dequeue will dequeue the smallest one. So we need a queue there. I actually don't know how to use queues in Python. I have not used that before. Enqueue and dequeue. Okay, so append and pop. Seems like this is the same syntax. That's append and pop. So we're appending, then once we have found another one, we pop the smallest index. Okay, so in this case we have found ABC, now we have another B, we pop the index of B. So now we are storing the index of A, C, and this B. Okay, so frequency is no change. Nothing here. Okay, next round we have an A. So we have index of A, C, and B. Now we have an A. A is in the dictionary, and this frequency's got 0, so we wanna pop the first A index. And we also need to move, so each time we find a letter that is in the T string, that we need to update the start index to be the smallest of the remaining ones. That's what I'm thinking, but it does not seem to be very efficient, but let's try that. So each time we find this, we want to update start index to be the smallest index in all of the dictionary indices. How do we get the smallest in dictionary? We can use values and then get the minimum, but that does that is not gonna be constant time unless we track, like just track a minimum number with another value, smallest. So smallest, each time we put in a index in dictionary, and smallest I. Okay. No, that's not correct yet. Okay, so when we have a no, that's not gonna be correct. Doesn't work. Start will be the minimum of dictionary values. So now when we are here, A will be popped, and for the rest of it we have B, C, B, A. Except that this index was also popped when we had another B. So what we are storing in the dictionary is the index of C and B and A. So that should give us the start index to be the index of C. That's what I'm thinking. And we also want to update index of A. So where are we updating that? B. Okay. That's what I'm thinking. So now we have a C, B, A here. Next round we have N, nothing happens. Then we have C. Then we have C, it is in the dictionary. Its frequency is 0. So we will pop the first C. We will move the start index to B and add this C in the dictionary. And now count is still the same. So we should be updating this start and end. And in the end, what do we want? We want to return the substring from start to end. Well, this is what I'm thinking so far. I'm pretty sure it's missing some or a lot of elements, but this is the basic idea. Unsupported operands types for so that does not work. This is usually how I do it in other languages. So how do we do it in Python? Okay, for now I do not know, so let's Just remove that for now. Wonder how to get that in Python letters. Okay, Python letter frequency array. So what do we want here? We want to be able to go to each letter right away depending on its position in this table. Okay, let's try that. Word. Int a list. If why is that a list? Oh, okay, so start is a list. Meme of that. Print start to have a look. It's empty. Okay. Minimum of dictionary values. So is the dictionary currently empty? Dictionary. Is it because we have... Why would this dictionary be empty? Let's see which test case it is. Yes, we're doing the first one. I9. Okay, so we are here. Here at B. At B. It's in the dictionary. Wanna pop B. I see. Okay, so at least that is correct now. Okay. So what do we have here? Still. Okay, so that is returning as a list. Can I put this into an integer? String, not list. Let's get the first value of the list. Okay, and it's I. Start to end. Is this end inclusive or not? Okay, if it's exclusive, then it should be +1. Let's see if this works. Nope. AB, output AB, B. It's because we put this. Oh, we did not take care of the case 1 is not found. Okay. Let's do that. So what if we just simply don't have T in S? If count is null. So after we have gone over all of this, we do something like this then. So we are gonna set start only when we have found it. Start is null. Invalid syntax. I wonder how to translate that into Python. If start is still none, return empty, otherwise we return Okay, so when we have first time we have found a letter that we need, we also need to set its start. None. Okay. Oh, I see. It's because it hasn't found it yet. Okay. So first time. Okay. Let's go back to start being 0 and we update start here. And what do we want? So we need to find a way to know when t is simply not in S. So if we have gone over the entire string S and if count is not equal to length, thinking something like this. When we're at the last letter, and we have not found all the letters we need, then we can return empty. Okay. Wow, it's been an hour and I'm falling asleep. B output is AB. AB. Okay, it's been an hour, so I'm gonna pause here and then take a short break. Then I'll come back and continue to record this. So I'll see you in the next one.